Okay, the first problem for the practice test is to factor. So we do not have to solve this. All we have to do is factor it. So the first thing I'm going to do is look at it to see if there's anything that I can pull out. I notice I have some x's, but there's no x on the 20, and there's nothing that can factor out from a number. So I'm going to have to factor it with AC middle. Now my terms, notice what they are. They're a fourth power and a second power. So that's a special factoring pattern. So when I do factor it, my factors are actually going to be x squared terms. That's what's going to be inside the factors, and I may have to factor further. So let's try AC. That's going to be equal to a negative 60. The middle term is equal to 11. So I'm looking for two numbers that multiply to negative 60 and add to 11. I believe that would be 15 and a negative 4. So 15 and a negative 4, but they will be x squared terms. So I'm going to pull out the 11x squared, and I'll replace them with these terms. So 3x to the fourth plus 15x squared minus 4x squared minus 20. Grouping that would be 3x squared times x squared plus 5. Now I need to have an x squared plus 5 on this side. And so because the sign of the original equation is a minus and it's a plus here, there would have to be a negative pulled out. So that would be a minus 4. So my factors would be 3x squared minus 4 and x squared plus 5. Now I'll look at those to see if there's anything I can factor further, and I cannot. This is not a difference of squares, so that would be my factored answer. Next one, it's going to be a sum of cubes, I think. Let's see if we can factor something out, and sure enough, I could pull a 3 out at the start. So that would be 3 times a cubed plus 8. Now remember, this would be a sum of cubes. Remember what that formula is. That would be a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So let's go ahead and figure out what a is here. A would be equal to the a, and b would be equal to 2, the cube root of a cubed. And the cube root of the 8 is 2. So let's go ahead. And we would have 3. That still has to be in the factors. Then we would have a plus b. Then I would have a squared. Now here, if I would have something where a would have been 2a, and then you square that, you have got to square the number also. Now, of course, we didn't have anything like that, so I don't have to worry about that. I just wanted to mention that you have to square the number. So this would be a squared minus 2a plus the 2 squared would be 4. Okay, moving on. Okay, let's look at this one. Well, it looks like we can factor a 2 out. So if I factor a 2 out, I get u cubed minus 216. So what? This is not. Oh, so if I look at this, u would be equal to a would be equal to u, and the cube root of 216 would be 6. So b is equal to 6. And let's go ahead and write that formula up there for the difference of cubes. A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So let's go ahead and plug the numbers in. The 2 is still out there, so I need to leave that in the expression. Then I would have a minus b, that's u minus 6, then a squared would be u squared, plus ab would be 6u, plus 6 squared, that's b squared, is 36. Okay, the next one is a cubic. Now, if it's not a sum or difference of cubes, and I can't factor anything out to make it a squared, I really don't have a lot of methods to factor cubes. I have a difference or sum or difference of cubes, and I have grouping. So hopefully I can group this one. So let's take a look. If I cannot factor anything out, let's split it down the middle. And I could pull a 5 out, a 5r squared out of this. And I would have 2r minus 3. Now then on the other one, I need to have a 2r minus 3. It would also have to be a factor. So what would I pull out to give me 2r minus 3? It looks like I would have to pull out a minus 8. Let's check the sign. This is a minus sign. This is a, and I have a minus sign here. So actually I'd be pulling out a plus 8. Let's check that out. 8 times 2r is a plus 16r. 8 times a negative 3 is a negative 24. So that works out. So I have 5r squared plus 8 times 2r minus 3. And that would be my factors. Okay, let's move down to the next factors. Now these are not on your sheet, but I thought we should cover it. Some special factoring patterns. All right, so what we have here is, remember the pattern I'm looking for is if the exponent on the first number and the exponent on the second number is 1/2 of that, and this is a constant term, then I have a special factoring pattern. And sure enough, that's what this turns out. So I can really think of this as like x squared minus 7x plus 12. So I will factor it just the same as I would factor this expression, except instead of having x's, I will have x plus 5s. So I'm looking for two numbers that multiply to a negative 7, add to negative 7 and multiply to 12. Well, that's going to be a plus 4 and a plus 3. So my factors will be x plus 5 plus 4, and then x plus 5 plus 3. And this really shouldn't have been equal to 0. These are just factors, so we're not going to solve it. So what's next is I'll just simply say x plus, actually those should be negative 4s and negative 3, shouldn't it? So let's take that out. So I will have x plus 1 and x plus 2. Okay, let's move over to the next one. Let's see if that I have the same pattern. I have a first power, a square root is a 1/2 power, and then I have a constant term here, so I do have the same pattern. So it's going to factor the same way as if I would have 2x squared minus 7x minus 30. It's going to factor similar to that. Once again, this was a factor, so I don't have an equal to 0, except my factors are not going to have x squareds. It's going to have a square root of x as my factor. So let's go ahead and work this as an AC middle. So I have AC is equal to a negative 30. The middle is equal to a negative 7. Okay, I made a little mistake. It wasn't, the AC should be a negative 60. So my factors that I'm going to have here, I'm looking for two numbers that multiply to a negative 60, add to a negative 7. That's going to be a negative 12 and a positive 5. So rewriting the expression, I'm going to pair the negative 12 with the 2. So I'm going to pull out the centerpiece right here. I'm going to pull that out. And I'm going to have 2 x minus 12 times the square root of x plus 5 times the square root of x minus 30. We're going to group it. And now then what I can pull out is on the front one, I can pull out a 2 times the square root of x. And what that's going to leave me would be with the square root of x minus 6. So over here on the other side, I need to have the square root of x minus 6. And I would pull out a plus 5. And it looks like I'm ready to write it as a factor. So I have 2 times the square root of x plus 5. Square root of x minus square root of x minus 6. Okay, the next one, it says using Descartes' rule, we're going to figure out what kind of possible answers I can have regarding positive real roots, negative real roots, and imaginary roots. So what we're going to do to find the positive real roots, we're going to look and see how many sign changes we have in the original expression or equation. So I have a plus out here. Don't forget that's a plus. So a plus to a plus, that's not a sign change. A plus to a minus, now this is a sign change. A minus to a minus is not a sign change. A minus to a plus is a sign change. And lastly, I have a plus to a plus. So I have 2 sign changes. And so what that means is I could have 2 possible real positive roots or a multiple of 2 less. So I could have a 2 or a 0 possible real roots. Now let's do the negative real roots. Now these are real roots. One's on the positive, one's the negative. So what we're going to do is we're going to put a negative in for the x. So let's rewrite the equation saying 5, and I'm going to put a negative x to the 5th. Plus 25, negative x to the 4th, minus 19, negative x cubed, minus 95, negative x squared, plus 12, negative x, plus 60. Now let's go ahead and any place we'll take and we'll, for the first term, we're going to say, okay, if it was a negative and it was to the 5th power, that would still be a negative. So I could write the first term like this. The second term would be a negative to the 4th power. That would be a positive. So it'd be 25x to the 4th. The next term would be a negative cubed. That would be a negative, and since it's subtracted, that would be plus 19x cubed. The next term is a negative. That would be squared. So that would be a positive, and there's a subtraction. So that would be minus 95x squared. The next one is a negative x, and since the number in front of the 12 is positive, that would be minus 12x plus 60. So let's see how many sign changes that I have. I have a negative to a positive. There's 1. Positive to positive, no. Positive to negative, there's 1. Negative to negative, no. Negative to positive, yeah, there's 1. So I have 3 sign changes. So the number of real zeros I could have, or of negative real zeros, would be 3, or a multiple of 2 less would be 3 or 1. Okay, so let's go ahead and make the table. Now what we see is that this is a 5th power. So I could have a maximum of 5 roots, 5 zeros. Okay, so the possible combinations I could have here is I could have 2 real positive roots. Let me label the top. So I have, these are the positive reals. Here's the negative reals. Here's the imaginaries. And here's the total. Okay, and I have 4 situations. I could have 2 positive real roots and 3 negative real roots. I could have 2 positive real roots and the 1 negative real root. I could have 0 positive real roots and 3 negative real, and I could have 0 positive with the 1. Okay, and they all have to add up to 5. So if I have 2 positive and 3 negative, I would have 0 imaginary real roots. 2 and 1, that's 3, so I could have a possible 2. If I have 0 and 3, that totals 3, I would have 2. Over here, if I had 0 for positive, 1 for negative, I would have to have 4 imaginary roots to make the total number of roots equal to 5. And so that would be the table I'd get for the possibilities. You're not. All right. Okay, so what we're going to do here is we're just going to sketch. What we're going to worry about is the end behavior and the zeros, and we're not going to worry about the local minimums or local maximums as far as how high those peaks really are. So what I have here is, let's count up the total number of zeros that I'm going to have, maximum. I have a 2 here. Then I have a 1 here. And I have a 2 there. So that's 5. So that's an x to the 5th kind of polynomial. So it's going to start in one direction and end in the other direction, opposite directions. And because of this negative, I know it's going to start high and end low. So when I'm done, I would probably have some sort of a polynomial that looks like this, similar to that. So let's go ahead and add the zeros in. Now, anytime I have a squared, I'm going to have a repeated 0, and it's just going to touch that point and turn the other direction. So I have a 0. I have one of them at this term right here, where x squared, that's going to give me a 0 at 0, and I'm going to have 2 of them there because it's a repeated, right? So I'm going to put repeated, so I know that. And then I'm going to have a 0 at a -3 for this factor. And then I'm going to have a 0 at 6 for this factor, and it also will be repeated. That's going to just touch. So let's go ahead and add the zeros. I have one here at 0. I have one at a -3. And I have one at 6. Now I know I'm going to come down from the top, and I'm just going to, the repeated roots, I'm just going to put a little dot here so that we can remember those. Those 2 are repeated. So I'm going to come down from the top. I'm going to pass through the 0 at a -3. I'm going to touch the 0 at 0. And that's going to be similar to the shape. Now, I don't really know if these local minimums or maximums like this are going to be, or the local minimums are going to be how far down they go, but I don't really care. This is just a rough sketch, and that would work. So if you had these things going way down so that yours would go way down like this or something, that would be okay. What we're worried about is the zeros in the general shape. Okay, the next two are, we're going to have to write an equation that has least degree. So I'm not going to have one of the zeros that it passes through like we did in the modeling in the last section. So this is simply writing out the zeros. Now, and then putting them in factored form and multiplying them together. So when I look at this list of zeros, if I have a square root or an imaginary number, they come in pairs. So there are actually 2 more zeros in this list that aren't shown. A negative the square root of 3 and a -3 minus the square root of 2. Those 2 zeros are also in that list. So let's go ahead and write this as a function where the zeros are in factored form. So I would have x minus the square root of 3, x plus the square root of 3. So I've taken this root and put it in factored form. Now let's put this 0 in the factored form. That would be x minus -3 plus the square root of 2. And the other 0 in factored form would be x minus a minus 3 minus the square root of 2. Okay, let's go ahead and simplify some of this. The first one is a difference of squares. I have the same numbers and variables, one's added, one's subtracted. So I could write this first two factors as a difference of squares. That would be x squared minus the square root of 3 squared. And the other ones need quite a bit more work. That would be x, the negative would distribute, so that would be x plus 3 minus the square root of 2. X plus 3 plus the square root of 2. Now what these are is their difference of squares. If I think of it like this, I have the same variables, one's added and one's subtracted, so I can write that as a difference of squares. And while I'm doing that, I'm just going to go ahead and multiply this first one, or simplify the first one. That would be x squared. The square root of 3 squared is 3, so that's what I would have for this first piece. The next piece, once I write it as a difference of squares, would be x plus 3 squared minus the square root of 2 squared. So let's go ahead and work that out. So I would have x squared minus 3, x squared plus 6x plus 9, and then the square root of 2 squared would be 2. So I would have x squared minus 3 times x squared plus 6x plus 7. Now I'm simply going to multiply those together. So I have x squared times x squared. X squared times 6x is plus 6x cubed plus 7x squared. So now I've distributed the x squared over. Let's go to the minus 3. Minus 3x squared minus 18x minus 21. All right. Combine like terms, x to the 4th. I have 1x cubed here, so that would be plus 6x cubed. Let's look at the squared terms. I have 7x squared minus 3x squared. That would be plus 4x squared. Looks like I have 1x term. And so there's that problem. Let's go to the next problem. These take a lot of room. Okay, the next one, let's look at the factor list, or the roots, sorry, the 0 list. And I have an imaginary number, so I know that there must be the complex conjugate of a negative 2 minus 2i. So I have to add that to my list. And now I'm going to write everything in factored form. So that would be the minus 3 0 would be x plus 3 in factored form. I would have x minus 2 plus 2i, x minus a minus 2 minus 2i. All right. So I have x plus 3. Distributing the negative, that would be x plus 2 minus 2i, x plus 2 plus 2i. This is a difference of squares again. Notice that if I treat the x plus 2 like its own little, in parentheses, that I do have a difference of squares. So let's go ahead and simplify. Okay, so writing it as a difference of squares. Let's go ahead and simplify more. X plus 2 squared, that's x squared plus 4x plus 4. Now, negative 2i squared, that would be 2 squared. That would be 4. I squared is, well, let me go ahead and do one more step so we can see that. 4i squared. All right, so and 4i squared is a negative 1, so this will be plus 4. So now I have x plus 3 times x squared plus 4x plus 8, and I multiply those together. So I would have x cubed plus 4x squared. X times 8 is plus 8x. Let's move to the 3 term. 3 times x squared is plus 3x squared. 3 times 4x is plus 12x. 3 times 8 is plus 24. Let's combine like terms. So I have 1x cubed. I have a 4x squared and a 3x squared. Looks like that's 7x squared. I have an 8x and a 12x. That's plus 20x plus 24. And that's that one. Okay, this one's also modeling, but we have one little piece of information. One, it doesn't say that it has to be a polynomial with the leading coefficient equal to 1. So the a value of this could actually be something different than 1. So what this will be is this is going to be some function which is going to have a times my zeros, right? However many I have. Whatever I want to call for zeros. So what I need to do is look at my zero list and highlight the zeros, and I'll need some other point that the function passes through that is not on the x-axis, not one of the zeros. Well, here the y value is 0, so that's a 0. That is one of my zeros. That's one of the zeros. That's one of the zeros because the y value is 0. This one has an x value of 0. That is not a 0. This is the point that the function passes through that's not one of the zeros. So what I'm going to do is I'm going to write the function by taking my zeros. And so I'm going to have a, and it will be x minus the 0. So x minus a minus 1. That's x plus 1. Here I have x minus 2. And here I would have x minus 5. Now then, I don't know what, and I'm going to take the f of x, and I'm going to change it now to y, because we know that it's a function. And now what I'm going to do is I'm going to substitute in the values for x and y in the point that it passes through, because that still must be true for this equation. So I'm going to take the y value as 5. The x value is 0, so 0 plus 1, 0 minus 2, 0 minus 5. 5 is equal to a times 1 times a negative 2 times a negative 5. So it looks like 5 is equal to 10a. Dividing both sides by 10, I get 5 all over 10, which is 1/2, is equal to a. So now that I found what my a value is, I can rewrite my equation as y equals 1/2 x plus 1, x minus 2, x minus 5. Okay, determine whether the function is even, odd, or neither. I'm going to do this by substituting in the value of 1 and a negative 1. Okay, so let's try that. So if I put 1 into this equation, I am going to get, so I'm putting in 1. What am I going to get out? So I'm going to put 1 in. That's going to be a negative times 1 cubed plus 2 times 1 minus 9. So I am going to get a negative 1 plus 2 minus 9. That would be a negative 1 plus 2 is 1 minus 9. I get a negative 8. All right, let's now put a negative 1 into the equation. And I would get 1 times a negative 1 cubed plus 2 times a negative 1 minus 9. So I'm going to get a negative 1 cubed is a negative 1, minus 2 minus 9. A negative of a negative 1, that's 1, minus 2 minus 9. 1 minus 2 is a negative 1, minus 9, that's a negative 10. Now, if I would have gotten out, notice what I originally had was a negative 8. If I would have gotten out an 8, it would have been even. If I would have got out a negative 8, a positive 8, let's go back, sorry. Let's try it again. If I would have gotten out the same number, which is a negative 8, so if I would have gotten out a negative 8, that means when I put in the 1 and the negative 1, since when I put in the regular value of 1, I got a negative 8, if I would have got a negative 8 out also, that would have been an even function because it didn't change the value. If I would have gotten out a positive 8, then the number's the same but the sign changed, that would have made it an odd function. But I didn't get any of that out, so this one is a neither. It's not even or odd. This one is going to be one where it just says list the possible rational zeros. We don't have to solve anything. So what the possible rational zeros are going to be, here is P, here is Q. So the possible rational zeros are all the factors of P over all the factors of Q. So that would be a plus or minus 12 over a plus or minus 2. So let's list all the factors of 12. That would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. All the factors of 2 are plus or minus 1 and a plus or minus 2. So now all we have to do is make the list. So I'm going to start with all the factors in my numerator over the 1. So I would have plus or minus 1 all over plus or minus 1. I would have plus or minus 2 all over plus or minus 1. I've got plus or minus 3 over plus or minus 1. I've got plus or minus 4 over plus or minus 1. Plus or minus 6 over plus or minus 1, plus or minus 12 all over plus or minus 1. So right down here, I'm going to start a list for those. So my actual list is going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now let's list all the factors of the numerator over 2. So my next list would be plus or minus 1 all over plus or minus 2, plus or minus 2 over plus or minus 2, plus or minus 3 all over plus or minus 2, plus or minus 4 over plus or minus 2, plus or minus 6 over plus or minus 2, plus or minus 12 over plus or minus 2. Okay, so some of these will be duplicates. So I have plus or minus 1 over plus or minus 2. That's plus or minus 1/2. That's got to be added. Plus or minus 2 over plus or minus 2 is 1. Oh, I've already got it. Plus or minus 3 over plus or minus 2. That is not in the list. So let's add that. Now let's add 4 over 2. Oh, that's 2. It's already in the list. 6 over 2 is 3. That's already in the list. 12 over 2 is 6. That's already in the list. So my final list of all possible factors would be that. Now that, I mean of zeros, not factors, zeros. So that's my list. Okay, so in this one, we have the zeros, including imaginary, and they give us 1, 0. So what we could do is by using synthetic division, so I have a coefficient of 1, I have a coefficient of 7, of 12, of 14, and 20, and fourth, third, second, first, they are all there. So I'm going to use synthetic division with a negative 2. So bring down the 1. 1 times a negative 2 is a negative 2. Add those together, I get 5. 5 times a negative 2 is a negative 10. Add those together, I get a 2. 2 times a negative 2 is a negative 4. Add those together, I get 10. 10 times a negative 2 is a negative 20. Add those together, I get a 0. So sure enough, negative 2 was a 0. So now then what I have left is in factored form. This would be, of course, I still have my x minus 2 there, so I'm just going to write it quickly as x plus 2. And these numbers that I have left from synthetic division would give me x cubed plus 5x squared plus 2x plus 10. And now then I have a choice to make. I could set up a synthetic division on this unless there was an easier way to do it. So the first thing I'm going to do is look to see if I could group it. Now most likely I would have left it like it is right here, and I would look at the coefficients 1 to 5, 2 to 10. They have the same ratio, so I bet I can group it. So I would try to group this versus doing another synthetic division. So let's go ahead, and if I group this factor here, don't forget we already have one of the zeros. It gave us a 0 over here, so I'm going to go ahead and put zeros. Okay, we know x is equal to negative 2. They gave us that. So let's go ahead and factor the quotient that I got from synthetic division. So I would have x cubed plus 5x squared plus 2x plus 10 equal to 0 if I group it. I would have x squared times x plus 5. So I have to have x plus 5 over here. And I could pull out a 2. So I would have x squared plus 2, x plus 5 equal to 0. So now I can find the zeros of this. For the x plus 5, I would have x equal to negative 5. So here's one of my zeros. X is equal to a negative 5. And then I have to find the 0 for x squared plus 2. So what makes that go to 0? And so if I take the square root of both sides, x is equal to plus or minus a negative square root of a negative 2, which would be I times the square root of 2, plus or minus. So my final 0 would be x is equal to plus or minus I times the square root of 2, and there would be 4 zeros inside of that. I mean 4 zeros total. In the last problem, we're going to have to combine a lot of the techniques we learned. We don't have any zeros given to us. We have a fifth power. We're going to have to find all the zeros, whether they are real or imaginary. So the first thing I need to do is make a list of possible zeros that I could have. So my list of zeros is going to be all the factors of 8, all the factors of the coefficient of 1. So my factor list is going to be equal to plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So from that list, I'm going to choose one of those to use in a synthetic division and see if it is a 0. So let's go ahead and list the coefficients for synthetic division. I have a 1. For the fourth power, I have a 4. Then a 1 for the cubic, a minus 14 for the x squared, a minus 20 for the x, and a minus 8. And now I get to guess. So if I would guess wrong, like let's say that I would guess a negative 4, and I would do a synthetic division with a negative 4, I would have 1. 1 times negative 4 is a negative 4. I get a 0, negative 4, negative 3, 12. Where's it at? Oh, wait, I'll find it. So 1 times a negative 4 is a negative 4, add is a 0. 0 times a negative 4 is a 0. Oh, wait. Add, I get a 1. 1 times negative 4 is negative 4. Negative 28 times a negative 4.
That's -18.
Negative 18. Negative 18 times a negative 4. 72? No. Yeah. Obviously, it's not going to give me a 0 here. So that wouldn't work. So let's pick a different one. So if you don't get a 0 at the end, you have to try a different one. I'm going to guess at a -2. 1 times a -2 is a -2. Add, I get 2. 2 times a -2 is a -4. Add, -3. -3 times a -2 is 6. Add, I get a -8. 8 times a -2 is a +16. Add, I get a -4. -4 times a -2 is 8. I get a 0. So a -2 is one of my zeros. Okay, so now then, what I have left is I have a 4th power. And let me scan the coefficients. There's nothing I could do with that. So I'm going to have to do another synthetic division. I could either use the original list of zeros I had possible, or I could create a new one, which would obviously not have the plus or minus 8, because this would be a end number of a -4. So I could create a new list. I'm not going to. I'm going to still use the one I had at the top. So I'm going to have to guess another 0. I'm pretty good at guessing. Now I'm going to guess a -2. 1 times a -2 is a -2. Add 0. 0 times a -2 is 0. Add is a -3. 3 times a -2 is 6. Add, it's a -2. -2 times -2 is 4. Add, I get a 0. So I have x is equal to a -2 again. Now I could have used a -1 or some other one of my possible zeros. I just happen to get lucky when I guessed a -2. So now again, we're going to keep doing this. If I look at this is a cubic now. This would be an x cubed. And when I look at it, I don't really see that maybe nothing really pops out to me that I can factor it. Maybe I could, maybe I couldn't. But I'm going to go ahead and do another synthetic division. Try -1. 1 times -1 is -1. Add -1. That's 1. Adds a -2. -2 times -1 is 2. Oh, look, I got another 0. Okay, so I add that to my list. X is a -1. And now I have a quadratic left, and I'm going to check to see if I could factor that. If not, I could always use the quadratic formula. So what I have is, looking at what I have left, I have x squared minus x minus 2. So I'm thinking to myself, two numbers that multiply to -2 but add to -1. So how about this? X minus 2, x plus 1 equal to 0. So this 0 would be x equal to 2. X is a -1. So once I got down to the quadratic, I could have used the quadratic formula. I could have done another synthetic division, or I could have factored it. In this case, I can factor it. So I add that to my 0 list, and I'm done because I've got them all. Here they are. And that's it.